over the course of these conversations, we've been going macro, micro, macro, micro, and just trying to understand the fabric of the conversations that need to happen. And today was really on the fundamental stage. How do we get stuff to talk to other stuff that eventually ends up populating the digital twin? Ken, you want to do a quick intro?
Okay, I'm Ken VanBree, and my company is eBuilts. We do as-built construction photography using our own platform and several others. And I also chair the 2D imagery committee at USIBD. And one of the things that we've been dealing with in the 2D imagery committee is providing a standard by which we could interchange 2D images that were placed on correctly on plans according to the spec that we put together. And we are working with a number of the suppliers, software suppliers and service people that do building documentation to try and make that possible. We recently have been looking at some of the mobile scanner applications, which look to be much less expensive to do and give high enough accuracy that we could easily use them. We're looking at ways of combining the data from mobile scanners and other scanners with the static data from cameras to provide a simple way of having all those images available to facility managers in the future when they need them.
Excellent, appreciate that. Randy.
Hey, I'm Randy Paulson with Duke Energy, and so we're early in the journey of digital twin and basically real-time information sharing, at least what we're trying to get to with our construction partners and engineering partners and other suppliers. And so we're trying to move from what I consider sneakernet to where we're actually interacting, fairly seamlessly, and also trying to lower the bar for entry barriers, because we kind of make it very hard for someone to connect to us. And so it's sometimes it might be easier just to use somebody you've always used rather than to go another route because it's so hard to get connected to us. And so we want to resolve that as well. And that's it.
Excellent. Appreciate it. Jacob.
Hey, good afternoon. I'm Jacob Dalbora, Director of BIM and FM Services for McVeigh and Mangum. Just have a great passion for digital twins. So I'm here.
Thank you. Yes, and we'll wrap it up with Sid.
Hi, everyone. I'm Sid Shah, calling from Boca Raton, Florida. I represent OnIndus. I have a passion of technology and construction management. Work with a lot of healthcare and higher institutions in higher education space, and all of them are moving towards BIM, or they all want to go towards digital twins. I'm here to learn more and share what my owners are asking to move forward to. So that's really early start of digital twin, but there are talks happening right now in higher education and some government entities I work for.
What we're trying to accomplish in our session today is to kind of challenge the way we're looking at things, and we've taken on this new process of identifying what that means by how might we in ways that so we're getting some results out of this. So really today what we're trying to do is get down to the fundamentals again. We keep going back and forth between macro and micro level to understand those nuances, but how might we understand the fundamentals of data interoperability in ways that reveal the roles and responsibilities required for seamless project-based system-to-system integration, so that we rethink traditional design, build, and operate practices, right? Because all this stuff has to tie together and be practical for folks to execute in the field, practical for folks to design in that process, and then flow all the way through to the operation of that asset. So that's the goal that we're going to look at today. Anto and Darren, as I mentioned earlier, are going to be the folks that give us the primary initial subject matter expertise. Welcome anybody on the call really to ask questions as we go, provide input as we go. But these guys will be giving us some primary thoughts as we step through it. So folks who've been in the room before have seen this slide. For those you have not, when we look at a project from its initial conceptual phase all the way through operation, there's this concept called the golden thread, the data that gets created at the beginning of the process when it's but a twinkle in folks' eye, all the way through operation. So that way, when there's a requirement to check the warranty status on something, something's broken and we need to replace it with some other asset. There are elements here that tie everything together, and the elements are the data. So that's the filter and the lens that we're going to be looking at as we look through this process, and it crosses each one of these phase boundaries as we go, and then you'll see the boundaries of alignment, realization, and certification. These are hoping to get things pushed as forward into the process as possible before that boundary of alignment, because as you make your steps to the right, things get more and more expensive to change, and sometimes are impossible to change, and or we've lost the ability to collect the appropriate data. So that's really the filter that we're going to look at here. Just wanted to remind folks of why. Now, some of the things we're going to go through, both in previous sessions, we're going to go through today, and I'm sure will come up in other sessions. There are different styles that folks have, and there's a spattering of folks in the room that are new to the concept of digital twin and are going to be trying to form their opinion and perspective on things. And then there are folks that have been in the game for a bit, are construction technologists by trade, or have had some practice in trying to do this. And you know, at the top of the pyramid here, or triangle, you have the scientist who is questioning everything, but in an attempt to learn. They want to try to gather some of this. And it goes all the way to the other end of the spectrum, whereas the scientists say, I might be wrong, but here's what's going on, to the cult leader, as they have it labeled, which is, I know I'm always right. Now you'll notice the asterisk at the bottom that very clearly, and I reminded my wife of this morning, that it does not apply to my spouse, who actually is always right. So that's the one caveat we can always put out when looking at the cult leader. But just ask that when you're considering things that we're talking about today, and in any of the other sessions that you join us with in the future, just keep these things in mind, so that way we can have an engaging conversation. We can respect the perspectives of other folks on the phone and really and learn from each other. So what we've done is we've brought different folks together today to talk about different things, and you'll see there's project level requirements for people. There's standard processes that are at an industry level, and that there are exchanges of information along the way. And this Venn diagram kind of shifts around at any given time to help us see how all these pieces come together. And when we have the conversation today, I think you'll be hearing quite a bit about how Anto is proposing this idea of a profile to help join some of these things together in a meaningful way.
Okay, great. So this is really a discussion about connection profiles, which is something that came out of our work last year. And we have introduced this concept to the Digital Twin Consortium, and is now being sort of discussed within that organization. And the challenge, I've been in integration of systems for about 30 years, as I mentioned earlier. And when I started to get involved with Digital Twin, I kind of looked at it and said, no, this is really an integration challenge, because there are many different elements of the Digital Twin, especially across the life cycle. And really the thing that's problematic with the concept of digital twin, not problematic of the concept of it, but the problem that we're trying to solve is, how do we collate all of these data together, right? So that it breaks down the silos. And so when you actually start to think about that, there are obviously challenges with that. Things like, protocol and ontologies sort of get in the way. Connection profile is a mechanism that really cuts through all of that. And that's what we're trying to validate within the Digital Twin organization, with the Digital Twin Consortium. And the intent is to create a integration mechanism that will work with any and all protocols and ontology and semantics, right? Which sounds like a challenge, but I'll show you the thinking behind that. So the landscape of digital twin, the sort of one way of sort of looking at it is that we're twinning real world entities that could be anything from a sensor, lonely sensor, all the way up to SaaS services and everything in between, right? So the scope is pretty broad. And really, when we're creating a digital twin, the way we look at it from a connection profile perspective is that what we're creating is what I often refer to as a digital fabric of nodes and connection between nodes, where each of the nodes are virtual representation of these physical entities that we're trying to help manage and improve performance. And so we have this fabric that's essentially connecting these nodes in some sort of manner that is designed specifically for some outcome for humans and potentially robots down the road, but we don't need to get too much into that. So this is kind of the digital twin, the kind of a simplistic way of thinking about the digital twin. And really this is where the concept of systems come into it. Because if you look at this picture, what we actually have is that there are two systems here. There are two classes of systems. There's a host system, which is depicted by the gears here, which is by which the blue dots are somehow organized for the purpose of that I mentioned in the previous slide. And each of the blue dots is some kind of subsystem. It's kind of the way we're thinking about it. And so each of the blue dots is really an interface between the subsystem and the host system. So it's a virtual interface because these are sort of virtual entities that sit in some database. So these interfaces know about the host. In other words, it knows about the role of this dot in the host system, but it also knows about the subsystem, what it is, where it is, information that's relevant for the purpose of the host. Right? And this is done to do essentially one thing, is to make sure that we understand how this subsystem can consume data, information, and how it may be able to serve information to other entities. And what entities? Well, we're talking about entities within this digital fabric, right? So this is the mechanism by which any two of these nodes can actually establish communication, because one knows what it can consume, the other knows what it can serve, right? And so when they match up, that's obviously when we get value. So if you take the two nodes L and K, right? They are whatever they are, right? But the connection profile is the simplistic way of thinking about the connection profile is that it's a template, it's a model of how two things, such as what L is and what K is, can communicate across the twin, as it were, right? So the profile is something that we'll get into a little bit deeper in a while. The profile has a name, so it's clearly identified. Simplistically, a profile is a codification of a use case. In other words, L needs to communicate to K to do something, right? And the profile is the way of actually defining that. And when it finds, when the host system finds L and K that needs to connect, it actually establishes an instance of connection based on this template, right? So one is the client. We think of one end being a client and the other end being a server. Those are terminologies just to make sure that that they're not equal, right? They're given names. Each of the two ends are given names. One's client, the other one's server. So this is what we're going to delve into a little bit. Before doing that, we kind of want to just go through some use cases of this sort of system concept using this fabric. This is one way of thinking about our existing world. These are systems that we are probably familiar with one way or the other. And if you think about all of these systems, these are all cyber-physical systems of some type. What's behind these screenshots are obviously objects. You know, there are pumps and motors behind this one. There's air handling unit with fans and stuff, and buildings on this other one. So the concept of using the fabric, the digital fabric, is to overlay the fabric on top of these systems, right? So that this motor is then represented by this node up the top here, and the other motors over there, and everything else is as seen here. So that this provides a way within each of the standalone systems to connect entities with using connection profiles. All right, so this is kind of a starting point, but it becomes interesting because the way that these entities connect within a system can also be exploited by thinking of them as ways of connecting between systems. So these big lines, the big thick lines, are also connection instances based on connection profiles, but they're not just within one system, they're actually going across different systems, right? The mechanism is exactly the same, whether you're thinking about the thick line or the thin lines. They're just using different profiles. So they're all the same sort of mechanism. So this is one way of looking at it. Another way of looking at it is in an integration use case where the fabric itself is not actually overlaid on top of any of these different systems, but it's actually just sitting there with the purpose of integrating the different components which actually are in the different systems. So what you can see here is that this dot here is representing a building, and this dot is representing an air handling unit. And so the implication there is that the two are connected, which means that this air handling unit is in this building, and this chart, or whatever it is behind the chart, is also related to this building, right? So it provides a mechanism of connecting different things across different systems as an integration. I love the digital thread, the golden thread term that you used earlier. In digital twin, we think about the digital thread, right? Which is how do you aggregate or organize the data across the life cycle of a particular thing, right? So this is one way of depiction. This is a simplistic kind of life cycle of X, where X could be a boiler, or it could be any kind of sort of other entity, real life entity. And the lines between X and all the other dots are connection instances created in the same way as previous slides, previous use cases. So what we're basically saying here is that the boiler was sort of instantiated right at the beginning at the design phase. A is some kind of design tool, right? So that has a relationship to X, which at this point is just a virtual boiler because it doesn't really exist yet. Somebody's just wanting to put the boiler in the design. It may also be owned by something, by some entity. And as it progresses through life, maybe it goes into BIM, and then it gets connected to a BIM system of some sort, and then it goes into the bill of material, and then eventually it gets installed. It's actually creating multiple connection instances, where each of these instances pertain specifically to what A, B, G, and J is doing, right? So they're different instances, based on different profiles, but they all relate to X. So the concept behind this is once you sort of get all the way to the end as far as this time is concerned, you then have N here, which could be a facility management system that has a relationship with X, but X also has a historical relationship with everything else it's ever seen in its lifetime, right? And each of these instances are likely to be different. And you know what's sort of interesting about this is that N doesn't actually need to know about K or F or J or any of the previous steps. It just knows about X, and X knows the interactions with all of the previous sort of systems, as well as sort of other types of entities. Right? So it sort of gives a mechanism to provide dynamic way of connecting systems across time. Right. So this is kind of an interesting way to look at that. If we dig a little bit deeper into these instances, which is really at the core of connection profiles, this is an instance between two entities. As I mentioned earlier, is based on a connection profile. So connection profile is essentially a template or a model. The other way I find is useful to describe it is basically a template for a contract of how a particular client is going to talk to a particular server, or a particular type of client is going to talk to a particular type of server. And it has a name. And again, we'll go into a lot more depth in understanding this. So once a twin discovers that two ends actually has relevance of actually the use of a particular profile, it then instantiates a connection between the client interface and the server interface, right? But what's important to note here is this is just metadata, right? This is metadata about how the actual client subsystem and the server subsystem actually will need to communicate with each other. This metadata is then available to both the client and the server instances. As you recall from the first slide I gave, the instances are representations of the real client subsystem and the server subsystem. So the metadata can then be pushed all the way down to the real subsystem. And the purpose of doing all of this, right, in this sort of consistent manner, is so that the subsystem itself, this air conditioning unit and this server, whatever they are in application, can actually establish communications across the internet using whatever protocol, whatever ontology, whatever mechanism it actually needs. Whether it's REST calls or using MQTT or any other sort of mechanisms that's appropriate. So this is the sort of the reason why we see this as an integration mechanism that can be applied across the board, because it really does not matter what the protocol or underlying ontology sort of meaning of data is. They can all be encapsulated in the template and then be replicated as instances whenever those use cases are found in real life, in project. So that's kind of a brief introduction to connection profile. I want to move to the implementation side of the implementation flow of connection profile, how we see this being used. Happy to just pause a moment if there are any sort of nagging questions or things that people have on their mind.
Yeah, I think, Darren, this is probably a good spot for you to jump in and take it from Johnny on the ground or Darren on the ground to go, yeah, thanks for that. I get it, but, right? So if you'll come off of mute, I can see you're still on mute. Give us your thoughts or questions.
Yeah, I actually do get it. I like a lot of what you're talking about. I think, coming from a mechanical contractor in the construction world, the problem I see with a lot of the people in the industry is we don't need a lot of information to get stuff done. You can sketch something up on a napkin. You can talk to a guy in the field and, okay, what do you need? Let me go. And I can go, bang some pieces of metal together and swing some hammers and we can make stuff happen. And a lot of this stuff, is just, it sounds like you're talking to somebody from Microsoft and not a construction company. So I think one of the challenges is how do we do something like this and bring along the people, the companies that are actually going to be maintaining, these systems, without burdening them with that type of, that information. Even I see all the time, some of the integrations that companies try to do, and, even internally and other companies I'm familiar with, there's all kinds of APIs. We can get information and we can push information, but we don't understand what we're talking to or how it works. I put my bird feeder out with seed long enough and the birds just think it's going to be there. They don't know that it could go away or might stop being filled. And that's when those integrations break. So I'm kind of curious how, Anto, how you see this thing working in an industry that typically has people that aren't very sophisticated in terms of protocols or, the APIs and how those work, even how we currently use APIs, that I can get information, I can pull information, but I really don't have any knowledge of the cardinality of the data that I'm I'm transmitting back and forth. I don't know how those systems work.
Yeah, and I see that gap, and it's actually a lot of the sort of rationale of actually creating connection profiles. Because another way of thinking about connection profile is as a way of enabling those API, the use of those APIs for integration, but in a way that's sort of abstracted, right? Because people don't care about the fundamentals of the API, but people care about use cases. If I want to do something, I just need to do this. And the destination of connection profile mechanism is a plug and play sort of mechanism, so that when you install something, the system or the systems will then discover what it should be connected to. And that's really sort of the focus of this connection flow that I'm going to go into next.
So would you describe that kind of like a USB connection works? I don't care if it's
Yes.
a speaker, a mouse. I guess I see in the like the fire alarm industry. You got a fire alarm control panel, but a lot of those devices are self-addressing, self-aware. It knows whether it's a strobe light or a pull station or a smoke alarm. But you're advocating for that type of kind of an infrastructure or interface, so that we could just plug these things in my industry and they just kind of work.
Yep. Just one word answer. Yes. That's.
Gotta love it when it's short and sweet. Before we get into implementation, it's really important that everybody has at least a working understanding of what Anto is proposing. Does anybody else have any burning questions that can help solidify that understanding before we move forward into the implementation flow?
Of course. Can you go back to the timeline one that you had? Just quick question on, so when X is established at the very beginning, what's the foundation for what's the underlying establishment? What gives it the first unique user ID and pushes it? Because typically we see that idea of A being the instance that becomes the foundation for it.
The beginning of the digital twin is a debate that's ongoing, right? So that's just to put that to one side. So there's kind of different views as to whether the digital twin should start at the sort of proto twin, or whether it actually starts when there's a physical thing, right? I'm of a mind that it starts whenever somebody starts to think about that thing, right? So my thinking of doing this timeline is a design tool. I don't know whose design tool it is. It really doesn't matter, but it has the capability of understanding connection profiles. And at some point in the use of that some user, presumably a designer, will do something like file add or whatever the sort of the command is. And it's really at that point that he or she decides that the boiler needs to be added, right? So in this depiction, that's when it starts, right? It may well be just a boiler goes here, right, with no other information, right? So the way in terms of who creates it, that really is sort of the role of the digital twin that's sort of aggregating it, the sort of the twin that's creating the digital fabric that I was speaking about in the first couple of slides, right? Because that's kind of the first instant that anybody has ever talked about this boiler. It's kind of the
Right.
way we think it should start.
Right, but is there a item already identified within that fabric for that boiler for then this to be associated to? So somebody's already pre-populating this?
Well, there is the connection is based on a profile, so there has to be it's basically a use case of requiring a boiler to be there in whatever tool it's being used.
Okay.
Right. So whatever that use case is kind of the driving force behind the creation of it at the beginning.
Does that tie into like a family, Jacob? Is that what the connection you're trying to put together?
Yeah. So I'm trying to think of in a BIM model, you're going to place a boiler, you have your family. So you place it down, boom, you automatically have now added this to the project, but it's more or less that A is what's establishing X.
Yes.
Okay.
In this scenario, yes. Obviously,
Okay.
there are different scenarios. Yes.
Correct. Yeah, there could be preset requirements already made that 6 boilers have to be here, so they could have already been populated.
Right.
And does that happen when the decisions are made? I guess, when I look at there starts out with the basis of design, and then there may or may not be a valve here. And that progresses to, okay, there more than likely will be a valve. Okay, yes, there is a valve. Okay, then, but we don't know what size or what kind, and that kind of changes. But there's a point when you start working on that basis of design. These things may not be here. It may, instead of A and B, that might be Y and Z, or a whole slew of other letters. When does that connection get made?
It gets made whenever.
I'm thinking like at the concept, or once we just, yes, this is going to happen. Or is it elastic enough that, we might do this, we see how we have an early twin, so to speak, and then maybe it changes later on as we, refine and change that design.
Or it may never go anywhere. It may just stop at this point and the project doesn't go anywhere, in which case that's that, right? So I think it's, I'm not quite sure how to respond to your point, but each of these applications has a specific purpose, and it has a specific purpose to have a relationship with X. That is the implication to this. What it's actually doing for what purpose, this mechanism doesn't prescribe or sort of define.
I'm kind of wondering, and I'm kind of in the camp there with Darren, and I think that was a great example about the valve. I kind of am wondering if during this design phase, the decision making of whether that valve is in or out is important. And so we need to keep up with that in the digital twin. Later, when we get into the build phase, all we care about is the valve there? Right. And I don't really care about the pain that went on during the design to decide whether it was required by code or not, or if they decided to put 1 valve in versus 2 or all that kind of stuff. That's extraneous information that just distracts the builder. And then when we get to operate, I don't even want to know about, the pain the builder had as far as how they decided to support the valve. I want to know what they did and how they did it. So it's like these connections and these letters kind of evolve as you go all the way through the project. And so and to your point, if you stop it early on, then it never evolves.
I see an interesting connection that just came out of that comment, Randy. And this ties back to something Anto said. As X moves along the plane, G and J and F and K, they don't know that A, B, G, and J exist before them, right? But you've created a relationship between the information. So the builder doesn't care about the design iteration that happened in A and B to get to the point where the builder says, I've got to put this in, right? And then the operator doesn't care that they tried 3 different valves to make it work because of some field condition. They want to know, what did we end up with, right? But you've already created the relationships with the data. So it's like water sitting in a pond. It's there. You're not necessarily going to do anything with it, but it's sitting there. But when you get to operate, you have something that happens in the future. It's a litigation process. Well, how did we get here? Because we've had a fire. Who installed the particular device on the wall? And who made the decision to pick that device instead of the other device? If you had to parse your way through all of the documentation and notes in 6 different systems, from your initial work in Revit, and then your stuff you're doing in Procore, and then your FM system, you're never going to find that evolution, that decision process that points to either this guy's at fault because we need to hold him responsible, or how do we find out where the fault position was so we avoid that in the future. As long as these relationships are established as it moves through that timeline, they're they're transparent to everybody else except for the one that it's important to. There's a pathway to get to that information. Is that a fair way to describe it, Anto?
That is, I was actually going to go there, but that is perfect. And you kind of, when you listen to that, you kind of think, okay, so 99.9% of the data is not going to be useful. But that to me is like, the cause of the silos in the first place. Because if you were to draw this digital thread of X in the existing or in the past way of thinking about it, they're completely separate, right? So it's absolutely impossible to do what you just said, or it's extremely hard, right? Whereas this provides that kind of mechanism. That's a great use case of the value of that. But I'm sure there are many other sort of use cases that are sort of less sort of dramatic as what you just said, that's sort of between K and N, relatively closer. So absolutely.
Okay. Well, I think in the interest of time, why don't we transition back into the deck and move forward in the implementation, and then we'll have some time at the end to kind of see how it all comes together, and then ask some further questions. Okay.
So the implementation is really thinking about how does this whole thing work with connection profile? Who creates everything, and how does it sort of get into the world, right? So there's sort of 4 steps to this. The first step is how do these connection profiles get created in the first place, right? Because everything revolves around connection profiles needing to be there. The best way of thinking about connection profiles is that they are codification of use cases, or specifically codification of integration use cases. And so we've done quite a number of these within the Digital Twin Consortium, and this seems to be the flow that works, right? So you would typically start with a use case, potentially a very sort of broad use case of needing to do something in a particular system or a particular environment. And typically when you start doing that, you start to break down the sort of the data models and what system needs what, where does data needs to flow, whatever data is. What we've then sort of done is to say, out of all of this work of figuring out how this use case is all about, you're going to extract what we call integration use cases, which are the specific points where 2 or more systems need to communicate with each other, right? That's typically how integration works. You sort of do this and you say, okay, there are 2, in this case, there are 2 server-client relationships, right? So what then happens, and we've done this, as I said several times, is that you take each one of them in turn, and you then explore, and this is just purely an example, so don't take too much of it on what's actually said here. Explore how A is going to talk to B, or how A could talk to B, and there could be multiple different ways of doing it, right? And if you just sort of imagine this as to your system A and I'm system 1, right, and we need to talk to each other, we need to communicate, then what we'll end up doing is just writing on a piece of paper, you need to provide this, you have an API, this, and you need to use this protocol, this is the URL, this is the endpoint location, I need to provide contextualization information about what one's need is, what the client's need is. And so essentially the connection profile is full of these sort of properties that sort of describe what each end needs to provide to make a connection, to make a connection happen between them. In this particular case, there is a broker involved, but there may not be a broker, depends on the situation. Right, so you do this, you may end up with multiple connection profiles because there may be multiple ways of doing this red to blue, right, depending on different types of circumstances. But you do this and then you create this connection profile out of it. And the connection profile basically says the server needs to provide this kind of information, the client needs to provide this kind of information. This is the name of the given connection profile. And the connection profile is to allow this type of server to talk to this type of client for a specific purpose, right? So the end result out of this part of the process is a connection profile, which is really, you should really sort of think about it as a specification of how these two connect. So you then go to the second phase, which is the development sort of phase, right? So here, you or I are developers or vendors of a particular system, how do we make the system compatible with a connection profile? So this is typically something that product managers kind of do. They look at the profile and they say, okay, our system needs to be compliant to that, right? So what is the process? So typically you would start with an existing product, a big software system that you're trying to make compatible with this particular profile. You probably need to add, some SDKs or other sort of interfaces to talk to the broker. And then what you need to decide is, am I building a server or am I building a client? In other words, out of this profile, you can be one or the other, right? Now you could be both because there are applications where you would need to do both, but typically you're one or the other. So if you're building a server, then what you're going to need to do is you're going to need to develop software to communicate with the client, right? But the client, the definition of what the client is and where the client is and what information the client is going to provide is already in the specification. And if you're building a client, the same goes for the server. So this is sort of almost like a closed loop software development sort of cycle, because this is the specification and you go and develop code. Right. Once you've done that, you develop relatively straightforward code. This will be using the APIs that we talked about earlier. You then test it, you then release it, and you basically go to market to say my product, Acme control system, whatever, is compliant to be a server of this particular profile or a client, or it could be multiple profiles. So this is how you build a connection profile compatibility into products. Then next comes the installation, right? And this is the plug and play kind of comparison comes in here. So you start off with a digital twin that is the broker that we're speaking about. Somebody installs the server, and as part of installing the server, they would instantiate the entity in the twin, representing a server. Somebody, maybe somebody different, would install the client equipment, and that would also instantiate the virtual interface. The digital twin then kicks in and says, okay, you two are talking the same profile, you're compatible, your client and your server, and you're in the specific domain that you need to talk. And then the digital twin then establishes the connection instance between the two, right? At that point, metadata flows. This is exactly the same as the previous diagram. And once metadata flows, whatever the mechanism involved between this client and server would then establish the communication across the internet, right? So that's kind of the installation process. This, implemented well, this becomes plug and play, maybe with some configuration parameters in some cases, but it really sort of removes the mystery, and this goes to the sort of USB. And then there's the life cycle of this, which is the fourth step. We start with the metadata link and the actual communication link. There's as a result of the installation. The metadata link is being continually monitored by the twin over the life cycle of the twin and of the building, right? So that it is in constant communication to both the client and the server, so that if something change for one end with one end or the other, for example, the server may go through maintenance and it may end up with a URL change, right? That would break this communication path because the APIs on the other end wouldn't know where to communicate. But with connection profiles, what happens is the server can actually just tell its virtual representation that the URL is new. It then distributes it to this client and maybe a whole bunch of other clients, and communication can actually continue unhindered. The same goes with any new entities that can be brought in over the decades of the life cycle. They can be added in, and if they need to communicate with one or the other of these two, then it will do that. Things can be removed cleanly, so you're not just unplugging anything. You're actually unplugging and telling everybody that this is no longer there. which then results in this sort of device replacement sort of benefit that you can remove this 3 years down the road when it's broken, and you can replace it. Maybe it's the same model, make and model, in which case it will just use the same profile, or it could be a different model or different make, in which case it will terminate this profile and it will establish a different profile with a different connection, and then it will just continue working. Right. So it actually makes the integration dynamic, which is really hard to do in sort of traditional thinking. And so the last sort of slide of thinking about integration more broadly, this is kind of the steps that I found over the years is kind of what happens. The top line here is really the traditional way of doing it. You write specification that's typically project specific. You write code that is typically custom for that particular project. And you install it, which is typically a manual process, and then you somehow operate and maintain it. It really needs to have the word pray somewhere in there, because usually that's involved here, because you're sort of relying on this to operate. In the connection profile flow, you create the profile, using the mechanism that I mentioned earlier, the use case sort of flow. You develop it in a product, right? Not as a custom code into a product, but you develop it as part of the product to make it compatible. And then the install becomes trivially simple, because it becomes plug and play, and the operate and maintain gets monitored over the life cycle. I believe, I don't have any data to prove this, that I know this part of it, this is very expensive throughout its lifetime, very risky, especially towards the end here. With this process, the first two, there's probably a similar amount of work in terms of writing specification, but this is a lot more strategic, and it's done by different people that's sort of wanting to make sure that it gets used over and over again. The profile gets used over and over again, the same with the product development. The install becomes really simple, and therefore doesn't cost very much, and the maintain phase is similar. So that's kind of how I see this in comparison with traditional ways of integrating different systems together. And the end.
I got a couple of questions, Anto, if I can, Kelly.
Yep.
This connection profiles connect node to node. Is that always a direct connection, or is it, is there going to be scenario, when I look at that, I think it's the mesh you called it, I can get to any of those nodes through other paths. Is that also allowed? Or because some of those other connections may or may not, I see that as potentially building, possibly building some resiliency into a digital twin, but at the same time, those other paths may not be designed for the communication that's needed between two devices.
It can do. It obviously is how you would orchestrate this particular fabric. I don't call it a mesh. I call it a fabric. Semantics, it doesn't really matter. It could be that this node is some kind of node that is monitoring the health of this, or doing some other sort of mechanism that will allow an alternate path. I'm not sure that's the intent of this, but I can see the benefit of that. There is no reason why any node can't communicate with any other node, as long as they have compatible connection profiles, and as long as they have contextual reason to communicate. Right, so that you need to be a contextual reason, either in the same building or in the same plant room or whatever the case is, and they have to have a compatible profile. As long as they have those two, they're good to go.
They would understand whether the data in an alternate path is there that they require or not. They should be self-aware at that point.
Well, the awareness is sort of one hop, right? But through that, you can build multiple hops.
Okay.
Right? So it's
my other concern with this, though, is just, all things being, Facebook, Apple, Google, and the monetization of data. If I buy a system, the fire alarm will connect to the control panel of that manufacturer. But do you have concerns that, that this might be embraced, but also monetized. Where if I actually want to build a digital twin, I've got 200 different vendors and manufacturers I need to now pay to flip that switch. I'm thinking of my days in the manufacturing space. You buy a Fanuc controller for a CNC machine control, and it's got every option you need in there, but you have to call and pay somebody to change that 0 to a 1 and turn that functionality on. I do have some concerns, I guess, is where, if there's not open interoperable standards that are demanded and defined, that, this could be kind of killed just by everyone's greedy monopolization of the data.
Yeah. So I believe that that relies heavily on the connection profiles, right? And who created them, right? I believe that the best way to create connection profiles is not a vendor, but an industry kind of collaboration around a particular that understands the requirements. This is kind of why this is kind of the who is like vendors of devices, but typically these are kind of in some kind of organization or nonprofit or something, right? That's, to me, that'll be the best way of doing it, because it's not connecting vendor A to vendor B. It's really connecting the type of vendor A and the type of vendor B, right?
Just like Logitech and IBM did not define the USB standard. They're just part of the... Exactly. Gotcha.
Right. That's the way I think it should happen, right? But interestingly, I think there's no reason why connection profiles can't also be created by vendors, right? And I think that's a double-edged sword, right? I think it's a good thing because it will actually allow vendors to get used to this sort of mechanism and implement it, right? The other edge of the sword is that it would provide a mechanism for vendors to have some kind of lock-in, right? But at least at that point, that there's a lock-in that can be replaced by an open profile that anybody can use, right? So that the debate on that particular question is, I would say, still open.
Jeff, I saw you raise your hand.
Yeah. So I don't mean to make this trite or oversimplify it, but it seems like this is sort of a mix of Zapier and Apple HomeKit, right? I mean, in a sense, the profiles end up being like the Zapier components, right? That are presets that you can hook up two different applications to create a workflow or Microsoft Flow. And at the same time, you also, whether it's BACnet, well, I would think it would be BACnet, or establish what those communication protocols, as you said, between those client and servers, it would benefit everybody to actually use a system like that. I mean, I used HomeKit as an example because it's just what everybody knows, or that, or the what's the Google version?
Google Home.
Yeah, Google Home. So, but I think, why things like BACnet or some of these others couldn't actually be used, I don't know. And then you're just essentially have a clearinghouse somewhere of all of these profiles for people to use. And I think, we were thinking about who would create these. And I think, it's kind of like any other product data that's out there. You obviously want to have either the manufacturer of the product involved or the manufacturer system creator, the control system creator involved. And there could be a third party in the middle that talks to either one or both of those and creates these profiles. Or if you go down this idea of a open source profile, then, the only development that has to happen is either on the product manufacturer side that says, yes, we recognize X number of protocols, right? They could support 3 or 4 different protocols. They don't have to support just one. And then on the software side, the same thing. And then it's just a matter of, picking one of those up and go. So does that sound about right?
Yeah, I think the comparison with Zapier is about right. I'm okay. Not familiar with the other Zach botnet. What the other thing that you were talking about? Sorry, but it doesn't matter.
Yeah, it's it's IoT protocols. It's an open IoT protocol. So
okay, I'm not that familiar with that. But the idea here is that this name here is unique and is registered somewhere in a similar way to a domain name is registered in the internet, right? So there is only one proso.example.sys, right? And in reality, it wouldn't be called. It'll be called, you know, bim.something. I don't know what yet. Right. So the idea is that they become standardized and available to use by anybody over and over again, regardless of the vendors on either end.
They're just schemas, essentially. Would
Yes.
that be accurate?
Yeah, schemas or models. I think I prefer to use contract as a sort of definition, because it basically contracts the server to behave a certain way and the client to behave a certain way, right? With both entities sharing information that they will know they have at the instantiation time, right? If you think about, you know, one of the challenges with the way we think about integration, right, in the world today, is that we have a sort of an endpoint thinking. Right, you have a server, you publish some APIs. I'm some kind of client application, and you know, I look at your documentation and I know how to talk to you, and you know what to expect from me. Right, it's kind of separated. Right, the connection profile takes a different spin on that and actually says, okay, there's the connection between two things is actually where the value is. Right, it's where data is actually going to be transferred. Right, so let's codify that. Define what all of the parties that are going to be part of that exchange of information needs to provide in terms of parameters and sort of ways of operating. Stick that in a connection profile, and then just use it over and over again. So you have this sort of a new way of thinking about a connection by knowing both ends at the same time.
I like that thought process, you know, because there's nothing that stops anybody currently from using an API improperly. And this is like you said, it's a contractual agreement on how these APIs will interact with each other so that they're done in an appropriate manner
for a specific purpose. Yeah.
So, Sid, you're a self-proclaimed new guy to the concept of the discussion. What do you take away from it? Because you're not getting down at the weeds in the IoT protocols. Does the concept resonate? You're on mute. We're not getting audio.
Yeah, the concept does resonate, but I think end of day, this data is owned by owner in most cases. You know, as owners' dime is at risk. They're the one who's planning which projects to go forward, which designer to work with, which GC to go with, and they're the one who's maintaining the assets in most cases. And so I see some owners who are actually brainstorming this idea of they may not be as sophisticated as node and client, but I follow what we're talking here. I'm working with an owner right now. They're scratching the surface. Let's get a GIS. Let's get the enterprise version of GIS so we can lay out our assets on the map. Let laser scanner all our facilities and point them with GIS, and use Maximo to use work coders so that we know what that appliances we have and what problems we're having on the GIS, on the BIM model. And on the front end, when we do a next level of asset replacement cycle, we have some sort of digital twin. We know what assets to be fixed and replaced. That's a vision they have. And it's connecting the BIM laser 3D drawing, connecting the Maximo node. They really don't have a standardized building management system today, but they're kind of want to move to that direction and operate on. So they're like at the stage 0, but there's a vision to get there. And I see that this concept will follow. And if you're a big owner with a heavy stake, when you're doing $1 billion of construction, some vendors will listen to open up their APIs for them.
Jacob, I see some head movement up and down on some of these concepts, and I've seen some eye rolls and head turns on others. What's resonating for you from the guy in the middle?
No, I mean, it's there, and really, I mean, this is basically what the full digital twin concept is about. A lot of the digital twin software vendors out there are pushing this concept as let them be that fabric, let them be the integration, and they actually then go and develop their own app store, right? Say, hey, Johnson Controls, if you want to develop an app, we will tie directly into yours, and we can pull the information, and our digital twin will show your information. Right now, it's I mean, in all reality, going from the design into construction into handover is what we've talked about all along, right? It's that drop off. It's that that moment that just the information doesn't keep flowing, and there is it's so messy. There's nothing there that is actually easy for a typical person or a typical owner or somebody to pull out, put together, and push into the next system. There's just a lot of headway to get that direction. I mean, that's what I do on a daily basis right now, is trying to automate exporting, BIM models into SQL so we can get it out. We can then pull the, BI dashboards and start looking at it as, analytics and information, and then continually update it as every week it says, they changed X, Y, and Z. So now we have 260 units of casework instead of 255, and our dashboard updates with it. But if you ever go look into Revit code and try and get that out seamlessly, it's a pain in the ass. So that's what a lot of the issues are coming from, is why we don't have too much sharing, is because the next person doesn't know how to integrate the data that's being handed over.
So Anto, I'm hearing a lot of concern about who's doing what, the level of effort that's required, what entities are actually connecting with each other to get this accomplished. One of the things you mentioned in our prep call was the relationship of the broker of information here. Can you explain a little bit more about that broker, and maybe that will help solve that? Understanding we have about 3.5 minutes left in the session.
So the role of the broker is to do the two things that I mentioned earlier. Is to be aware of, or the place where these virtual representation of these physical real things are instantiated, right? So that's in the broker sort of space, right? Now I'm using the word broker very generally, right? Because we're building a product in Paddy, and that obviously is a broker, so we have a certain perspective. But I think there's a much broader perspective, because connection profile is an open mechanism. But the first thing is the broker, or the twin is the place where things get instantiated, right? So all sorts of things get instantiated, and the broker then needs to do this task of matching the clients and the servers, matching the connection profiles, right? Which is relatively easy. The difficult part is matching the context, right? Because you don't want the boiler that's instantiated in a broker in one building to be connected to an analytics system that's related to a building on the other side of the world, right? So that's all about understanding the context. So the assumption is that the broker or the digital twin has an understanding of the context of that project, or of that asset, or of that grouping of asset, or however you want to describe it. So a broker could be a digital twin of a water utility, or it could actually be a digital twin of a city. So it understands the context of everything, right? And when it determines that entities within its scope have compatible connection profiles that would benefit from connecting, it would then go to them and actually connect them. Right. So that's kind of the mechanism. The connection profile mechanism itself really doesn't specify how the broker does this, and I don't think it should, because I think this is where a lot of innovation can actually happen. It could be geo-related, it could be manufacturer-related, and the other thing is that these fabrics can all sort of be stacked on top of each other, and they could actually be completely different fabrics. So a water utility digital twin may actually have an entity that's also in another fabric that's actually the geographical county digital twin that they've created for whatever purpose. And it may also be an entity, a node that's in the digital fabric that is from the manufacturers of a particular product, right? So all of these are kind of completely different contexts, but it's actually the same entity, the same boiler that's actually in all of them, right? That enables this connection profile, enables that boiler or that thing to connect to whatever's relevant in the context of the fabric, in the context of what the broker sees. And that may sound a little vague because it's obviously it's a new concept at this point.
Okay. I appreciate that excellent feedback. We have less than 2 minutes till the room's closed. That was the end of the session. There was one remaining question we didn't get to. John Egan, if you can throw out your question in less than 30 seconds, that gives a chance to answer.
Yeah. So, great. Thanks, Anto. I really enjoyed your presentation. I see challenges with expense and implementation and perhaps confused in who builds profiles, etc. Can you tell us a bit about the success of the project to date and the biggest problem that you see with the project so far?
The project is relatively new. This whole mechanism was only sort of created last year, beginning of last year. We introduced it into the Digital Twin Consortium as an open way of doing this about in October, November. And so what's happening in the Digital Twin Consortium is it's being sort of discussed and validated against use cases. And we're starting to learn what works and what potentially is sort of questions. I don't think it's sort of far enough along to say that this will work with everything. But I think it will work. It probably is not going to work for really, really complex integration where it probably is going to cost like $10 million to do integration. And it's not going to work to replace, let's say, using Modbus to connect two devices, right? It's really designed for system to system kind of integration, which is somewhere in the middle. It's trying to reduce that so we can actually do system to system integration scalably, consistently.
Excellent. Appreciate that feedback. We have 5 seconds left. I want to thank everybody for joining us today and looking forward to the next one.
Joe, you're in your COVID disguise. I just sat in a room with you and didn't even realize it was you.
Yeah. This is 12 months of no haircuts. That's what it looks like.
Do you have the full man bun? Are you able to rock it in Texas, or do they still give you crap down there?
Oh, it's outlawed down here, but I can pull it back. Yeah.
Well, at least you have hair.